Hello!
Hi. Welcome, everyone.
Questions in the chat.
Yeah.
Why do we keep doing this? What is going on? No, the question in the chat is more details about the dog walking, please.
Oh, yes.
And how do you see your past observations on squirrel life?
That apparently the squirrel life thing is a bit of a glitch that needs to get fixed. So we've told the person that runs the app that that's a thing. So right now it's not a thing that you can do. And if you are concerned about it, you can certainly get in touch with squirrellifeguelph@gmail.com and they can check. But don't worry about it, eh? Like, it's all good. Yeah.
You know what I'm realizing?
What are you realizing?
That's a question from last Wednesday's chat. So I'm going to close it.
Okay. You're in the wrong chat.
Although that would be a very interesting way to... Oh, there's a question in the chat.
Yeah.
About last week.
About last week. Okay. Now.
A question from the past.
What's a question from today?
Also observations about what we just learned, which was that while Orville Peck lives in Canada, he does not consider himself a Canadian.
No!
So that was kind of the last time you'll hear him in this playlist.
Okay.
Really? Yeah.
Okay. But it's cool.
I mean, you can always go and hear him.
The story's cool.
I agree.
Because Orville Peck isn't a thing.
Yep.
Except for, read about it. It's cool.
Pollywog in a Bog by the Bare Naked Ladies, part of the Snack Time album.
Great.
Right, we'll check it out.
Thank you.
Thank you, Snoo-To3.
Wonderful.
That is a great handle, actually.
There was something, do you have questions about what's going on with what?
Well, just somebody's asking about Theo.
Oh, yeah. Theo didn't work out.
Theo has worked out.
Theo, just not with us.
For someone else because of oversight.
Yeah, but we will introduce you to the cat that will be joining our family. His name is Taco. And that's fine. And we'll make sure to get him on a Tuesday.
We'll join him. We'll join on a Tuesday.
Yes. Okay. What else did we want? Do you have questions about what's going on with the information technology system at the University of Guelph?
I do. I have questions.
Yeah. Taco cat. Yes. So if you have questions, please feel free to pop them in the chat. And certainly if you want to stick around after class, we can talk about it. I don't know anything, but maybe you have some concerns that I may be able to help you figure out how to address or something like that.
Put in the chat, how many of you spent a lot of time in a line?
Yeah.
In
a very long line at the library with your account frozen.
Because vibrant.
So one thing that I will say is that because of everything, it's been quite a disruption for a very long time. We haven't been able to check our emails as frequently as we would like, and you haven't been able to get onto CourseLink and hand things in and all of that stuff. Let's all practice, deep empathy and understanding, and everything will be okay. If you run into any troubles, with folks who are not practicing deep empathy and understanding, let us know. We're pretty good at advocating for you and for your students, and for our students. So if we can be of any help with that, that would be great. I don't think that it has affected our ability to grade your topic test, but let me look into that because the TAs might have had problems accessing CourseLink to do all the grading, blah, 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 blah. So we'll keep you posted on everything. As of right now, though, I have no information to suggest that we are not on schedule.
I like that. Practice deep empathy, because there is a shifting ground upon which we are all working, and we realize that you are working on it as well, and we realize that for you it is not shifting because of things you're doing.
No. So yeah, we got you. We definitely got you in 1070.
Yeah.
We'll keep you posted on everything else. But yeah. Anyway, any questions that you have, please feel free to ask. As we move forward with things, there may be opportunities to ask a little bit more officially, publicly, look for town halls and things like this, discussions about what's going on at Guelph. And you know what, though, just generally, I'm pretty optimistic about things. They might get more challenging for a little while, and it might get stressful, and we'll be there to kind of prep you if that's the way it needs to go. But we'll keep you posted. Okay.
So before we go, do not erase that. I want you to use your annotation tools. Which one would you eat?
Oh my god. Oh, which one would you eat
Yeah.
and which one would you choose as your roommate?
Or as a stuffy. Yeah.
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 Awesome. Wonderful. Okay. And I think the waiting room is slowing down. And we should probably get on to class time stuff now, right? Because we're going to learn about moose, and that is awesome. Moose are amazing. Recently on, I don't know if it was TikTok or something, or Twitter, this beautiful, totally albino moose. Have you seen this video? Like Google it. It is, that creature is just a shout out to evolution and beauty. Okay.
Do we use Epic Collect or the Squirrel Life app to collect our data?
Whichever you would like. I would, if you can do the Squirrel Life app, if you're comfortable downloading that would be amazing. But you can totally get in touch with the Squirrel Life folks at the Gmail, so squirrellifeguelph@gmail.com, to ask and just make sure that everything's been properly registered. If for some reason, like this is like, okay, so one more thing. Sorry for the ones that are going, why don't they just get to the biology? But this, I think, is important. So at no point is, well, maybe at like a year after you take the course, but like almost at no point are things not changeable in some way. Okay. So if there has been a mistake, right, on your Squirrel Life stuff, for example, or on the marking on something, we can totally go in and change it if it's a mistake. Right? We're not allowed to go and just, up your grade because we want to. Like, that would set off a whole bunch of red flags that would get us into trouble too. But like, if we've made a mistake on something, we can totally change your grade even after it's been submitted. So like, if you think that there's something going on that you weren't able to check or didn't go through, just let us know. And we can totally fix things. And that happens with, any other course too, right? It's kind of part of the hidden curriculum where it sounds really official and final, but in many respects, there's quite a bit of leeway for mistakes.
So some additional Squirrel Life questions.
Yes.
Does it work without data or Wi-Fi? I did a walk with no service and I'm worried it wouldn't save. And I think some of your colleagues are answering, and I think you did need data.
Yep.
But if you remember some things,
just
put them in.
Put them in.
Yeah. Where can we find saved observations?
Yeah, so you can't at this point.
Yeah.
If you're worried that it didn't go through, you can get in touch and they will check behind the scenes. Liz Porter, future Dr. Liz Porter, my PhD student, is running all of that behind the scenes.
And since we've been talking about moose, and before we get to this, how many of you are from Newfoundland? Too fast.
Yeah, because that's a great place to be from. Well, there are many great places to be from, but we just launched the homework question for those of you that did the homework. If you didn't do the homework, maybe just select E to let us know. That would be helpful just to see how you're all doing with your time and your lives and all of that stuff. And I don't know the answer to this one, so I've got to figure it out.
There's a fire drill going on.
Fire drill? I think it's this one. Yeah. Okay, you're not doing amazing on this one. It's fine. Don't worry. It's fine.
Which is a lovely thing to say as people are still writing. Whoa, not going well.
It's not going well. No, it is not going well. It's not going amazing. But don't worry about it.
I'd re-express it.
How do you want to repackage it?
Boy, we got some stuff to talk about.
We have some stuff to talk about. Yeah, it's totally fine. Okay. So, which makes me, so when I see like a split like this, I start to wonder whether I could have been more clear in the question. So let's take a look.
I also love the fact that there's 80% participation on a Monday morning.
Yeah, well done you.
Well done you.
That's totally great.
So put your hands in the air.
Pat yourself on the back.
Pat yourself on the head. Just
Thank
give
you.
like a cheek massage.
Okay, cool.
One big massage.
I'm going to put it over here so that we can see this thing going on here. So basically it's like split 50-50 between these two things, where competition for water is the stronger, or water is the weaker, and then the other one is the stronger or the weaker, which is totally okay to work through. Good. So basically what we want to do is we want to compare two. So if I was going to take a look at light levels and how important they are, stamp for me which two treatments am I going to compare? Yeah, good. A and C, perfect. So let's take a look at A and C, because the reason why we're choosing A and C, for those of you that are like WTF, the reason why we're choosing A and C is because the level of competition for water is the same in those two, but it's the light levels that are different, okay? So take a look, we go competition for water, that's controlled therefore, right? They're both under competition for water treatments. And we look at low versus high light, and we see a 17% versus a 70% survival. So quite a big gap, right? So light levels are a significant, pretty substantial control factor. Okay, now let's take a look at competition for water or not. If we're interested in that, which two treatments are we going to compare? Yeah, B and C. And the reason why we're comparing B and C is because both of those have the same level of light. It can be low light or it can be high light. It just has to be the same, right? So we take a look at those two, 85 to 70%, and there's a difference there, but it certainly isn't as strong as the difference between 17 and 70, okay? So now we can choose, I believe it's water is the weak limiting and light is the strong limiting factor. So I think that one is C. Let's just make sure. Yes. Is that okay? I hope that's okay. We're recording this so you can go back and kind of work through the progression there.
The what?
The what? Yeah. Okay. Good. And pull. Moving on to moose. Because
clear the screen. Here comes the moose.
Here comes the moose, and you're going to talk all about moose. Because we like to talk about moose.
So these are, you can go back and check these later on, but we're talking basically, we're getting into some population things today. And you've probably thought about these things, and probably even in your training as a biologist or as someone who's had to endure the fact that the Simpsons are older than you are, and that for your whole teached career, people have given you Simpsons examples. There is an example about this kind of thing in the Simpsons when they go to Australia and take them cane toads. But we wanted to talk about moose because A, it ticks all the boxes in terms of talking about these things, these population things, and it's a Canadian example, and it's relatively recent, and they're delicious, and they're huge. And those last three things, Canada, delicious, huge, is not normal, and we should have more discussion about them. So in 1904 or 06, the records vary. So let's say 1905, which actually makes it the same year that this room that we're in was constructed. People in Newfoundland and some of the eastern excited states of America and Nova Scotia took 4 moose to Newfoundland. 4. Yeah, so the young, as you can see, so moose, as you know, if you're or if you don't, are giant, and so a lot of these. This is a picture of one of them. Persons in the picture are American government officials who accompanied the moose to this country, which makes it sound like there was a role. There was like moose accompaniment jobs.
A moose handler.
Yeah. Oops, sorry. And so This is some of the regions of donation that we know of in Canada in the perhaps '06. The '04 is probably from the States. But so one female and one male into the central area and up into the peninsula, 2 males, 2 females in 1904. So we have a case where the population for a long time seems to have had a hard time maybe finding each other, but they perhaps weren't eaten very frequently. And then they got to find each other and they celebrated the fact that not a lot of people were eating them. And so these numbers went bananas and up and high. And now the current numbers aren't as from 4 to 150,000 in the 1980s and 90s. Might be estimated to be around 120,000 now, with some big consequences to how people move around terrestrially in Newfoundland. And in this case of that province, Newfoundland and Labrador, we're talking about the island, about Newfoundland. Right?
What might we predict about the genetic variation in this population?
Yeah. So, did we move past one, or was there? Yeah. Okay.
That's it.
Thank you. So one of the things that we've talked about, or that you've experienced for those of you who are from Newfoundland and Labrador, is that, oh my goodness.
What's going on?
I've given you a link to the data, silly me. So you can go back and click that when you get the PDF and go and look at those data. Some of you who may have been to Newfoundland and driven around have seen various iterations of these kinds of signs, and you can buy them on T-shirts because people love them. People have been stealing them since the provincial government started putting them out. But this is human-moose conflict is a serious thing because 700 plus vehicle accidents per year. This is in a province that does not have a lot of roads nor a lot of vehicles. This is an aberrantly high number, and that's because, as that diagram suggests, when you run into a moose,
it runs into you.
It runs into you. Basically, you break its legs and it falls over into the hood into the windshield of your car. So it's not just a fender bender. It's often a death. So there have been a lot of issues or a lot of work done in the province with provincial biologists and provincial people to try and figure out how to live with the moose. And one of the options that's available to them is, of course, because this is a large thing and a delicious one, compared to perhaps the cane toad example in Australia, is that maybe this is a thing for which you could harvest, you could eat. And so you can go and find different recipes in the moose management plan that are closely linked to the bologna plan. But from a biological, so this is kind of like a sociological perspective or a food, I'm hungry right now, or I will be soon. From a ecology perspective, as we talk about this example, we're going to talk about this example, try and keep it in your head for a bunch of the variables that would have come into play over this real world example that's taken place in the relatively recent history in the past 115 years, 120 years or so in our country. For an inoculation or an introduction of 4 human facilitated to a current population of approximately 120,000.
Yep. Amazing.
Yeah, there's some comments in there. So we've got, that's a lot of inbreeding.
That's a lot of inbreeding.
Moose always wins.
Yep. Meese.
Yep. Delicious.
Delicious.
And there's of course some other some gorgeous examples.
Yeah.
I mentioned the cane toads, but I mean, all sorts of things have been introduced by colonizers into Australia, including rabbits. If you've watched Narcos, or maybe if you're old enough, you remember Pablo Escobar, but hippos are a thing now in Colombia because of Pablo Escobar, and because once hippos are adults, there's not much you can encourage them to do except whatever they want.
Yep. Wonderful. Watch Narcos. It's cool.
Yeah.
Population of Burmese pythons in Florida.
Yeah.
Right. So,
Hi.
Yeah, I mean, and all sorts of other introductions of snakes into places, like Guam, for example. So it's really quite a thing that humans do. In fact, I might argue it's one of the things that characterizes our species. We move things around.
Yeah.
And so we're responsible for a lot of this stuff as well.
Yeah, and so there's great observations and discussion both about moose burgers and about the fact there's some observations about inbreeding. Would that have a founder effect? And it's yeah. So bring these things with you. Congratulations you for bringing those things from the last unit back along with you.
Yep, excellent. Good. Yay.
Moose versus hippo versus rabbit versus python. Who wins?
Hippos.
Hippos are
I think
so-
win like every time.
Like a moose is, but I don't think they're as angry. Hippos are just born angry.
Yeah.
And they're terrifying.
Yeah. Okay. So we're talking about populations. We're talking about population growth, and the way that things kind of settle out. So take a look. Actually, let's just go back
Yeah,
here.
that's a great.
This is a fantastic graph that's down here. Thanks whoever put the heart like in the perfect place. So yeah, we see this type of curve. This is like a thing that we notice, and we saw it just a few seconds ago here as well. This type of like nothing's happening, and then all of a sudden something's happening, right? And then things kind of die down, and you know, that kind of deal. So that's really what we want to talk about today, is to introduce that idea of like, why is nothing? Oh shit, right? So this is we'll do the oh shit moment on the graph. Okay, but when we talk about populations, and remember, like we've been talking about, different biological levels of organization and their associated variables, the stuff that you can measure in that level. And I know that that's like a thing that's like, what does that mean? So what we want to do is we want to kind of list them for you at the population level, and you can go, oh yeah, okay. So when we talk about populations, we can characterize populations using a whole bunch of different metrics, right? When we talk about communities, we can do that using a whole bunch of different metrics, like the indices that we talked about before, the Shannon Diversity Index, alpha diversity, beta diversity. Those are not things that you would necessarily use within a population, okay? They're things that you would use in a community. So here are some things that you can use within a population. So,
and a shout out in this first bullet to the marine and freshwater people, because
Yeah.
we're talking both about their distribution of the animals in the population in area, but also, or in a volume.
In volume. Yeah. Good. Thanks. Okay. We can talk about distribution. We can talk about abundance, right? So distribution is like how they're distributed throughout a space. Abundance is just the number within that space. We can talk about the density, so the number per space, the birth and the death rates, the sex and age structure, the fecundity, the fertility, which are different things. And we can talk about production, which is different than fecundity and fertility. And we can talk about recruitment, which is different than fecundity, fertility, production, and recruitment. And these are all things that that really matter. So if somebody asks you a question about the production of something, they mean something very, very specific. So we have these terms for you to be able to go in and, kind of understand. I hope it's pretty clear what some of these differences are, right? Fertility is the percent of eggs that produce viable offspring, whereas the fecundity is just the total number of eggs. Okay, and these things really do matter. They tell us, the difference between these numbers tell us something important about the environment or the context, right? Okay, so for example, we can look at abundance and we can look at density, okay? And it really matters for the species that we're talking about, right? We can take this whole bunch of ladybird beetles and we can say, okay, there's like 50 per meter squared. That's like a huge number of ladybird beetles. Or we can look at diatoms and go, 5 million per cubic meter. That's about average, right? And whether or not it's a high number or a low number, it cannot be compared across species, right? But you can certainly look at it across habitats or across contexts or across time within the same species. So the population is your unit of comparison. And we can look at abundance over time, right? From time 1 to time 2. Really, it's just the change in the total number of individuals from one time to another. But let's just kind of break it down and make it complex. So we can look at population at time 1, right? Say now. And if it's going to increase to population at time 2, right? If this number is going to be increasing, then that's going to be due to 2 things: births and immigration. If it decreases That's going to be due to two things, and I'm going to guess you know where I'm going here. That's death and emigration. Okay, so either things are leaving or they're dying.
Hatching, matching, dispatching.
Nice. I like it. Okay. So what does that formula look like? You can memorize this, or you can just common sense your way through it. Doesn't matter, whatever works for you. So population of time 2 is equal to population at time 1 plus births minus deaths plus immigration minus emigration. And that gives you your population. Or you can just go, okay, does birth add or take away? I'm just going to subtract or add it up, and it's all going to work out. Either way is totally fine.
So you can see in that kind of very simple equation, it's kind of, I mean, if you haven't thought about or don't want to think about it in terms of hippos or geese or moose, think about it as your daily budget, like your bank account. What you've saved is worth what you're bringing in versus what you're spending versus what you're like finding on the street versus what you're losing from theft. It's like it's a very simple kind of an economy. Elegant is how scientists like to. So it's a good starting point.
Yeah,
it is simple. Things change because this is going to take place in an environment, probably with weather.
Yeah.
What is that?
Okay, good. So we can also look not only at abundance, but the way that things are distributed within a space, okay? And we can describe it in 3 ways.
Sorry, there's a moose breaking into a house. I need to know more.
Oh, okay. Okay, so we can describe it in 3 ways. The first way is clumped. The second way is even. And the third way could be random, but we disagree, us too, about what random is. I don't believe in random. Okay, so clumped clump distribution means you have the same number of individuals within a space. It's just that they are clumped together. So usually associated with distributions around resources. We have an even distribution, which is usually associated with social interactions between individuals that might include things like individual territoriality, like this is my space and you can't come in it even though we are the same species. This is just my space. And then random, which is usually associated with me not being able to figure out what the F this actually implies. Random is seemingly not related to resource, and there are some instances where random can happen, for sure. But then why talk about it as a distribution? But anyway, he's holding his, thank you for being patient with me. Okay, so let's take a look. All hail King Geese. Yes. Let's take a look a little bit at some examples of these distributions. So clumped, we have, for example, butterflies that are attracted to sources of water or nesting habitats and things like this, right? They're all coming to, for example, you think about monarchs in Mexico, they are clumped as they get together in order to reproduce around these trees that just fill up with them, right? So we see these clump distributions.
People think about toads and amphibians like this all the time.
Yeah.
Because you don't find an even distribution of salamanders outside, or you find them near ponds.
Right. Even distributions, like seabirds, are really even, are just far enough away so that they don't peck each other's eyes out, but they're able to benefit from the colony itself in terms of keeping away predators. So they are very territorial over very small spaces, but really you don't want to step into their space because they'll be nasty. And then, random could be things that are growing next to each other, but for no real kind of reason, no relationship that they have. It's just where the wind brought their seeds, and that's where they are.
Lots of marine things, so or freshwater things in kind of a big dispersing environment, thick, viscous environment like the sea.
Yeah. Okay. So tell us, using your stamp, which do you think characterizes the distribution pattern of humans? And go. Clumped, even.
I'm going to ask a question out loud that I asked in the chat.
Yep.
Which was, what kind of biases do you think you might bring to the game if you were studying species like of these three categories? What kind of biases might you bring as a human?
As a human.
To studying them.
Yep. Pop those answers in the chat. That's a good one. That's a tough one. Okay. Cool. So, I'm going to have to clear.
Yeah.
I'm so sorry. These drawings are fantastic, but I have to clear these stamps.
Can something be random clumps? Like clumps, but randomly distributed?
Randomly distributed on the landscape? Yes. Mm-hmm. Not randomly distributed for other reasons, like mating. Like where they mate may not matter, but they are clumped in order to be able to mate. If
they're a sexual species.
That's right.
Yeah.
Yeah. Okay. I'm going to have to clear. I'm so sorry. Your drawings are beautiful. Okay.
Thinking of all the species that have the same reasons as humans to do what they do. So yeah, that's a good bias. So we're just like a lot of biases. We would tend to be more intuitively probably funding and able to imagine studying species that distribute themselves similar to how we do. And let's look at how we do.
Yeah. You know what I'm thinking? We may have to save some slides for next time because I'm really liking this discussion and I want to kind of slow it down. So maybe we'll do the zombie stuff next time.
I think there's always time for zombies because zombies just count out. I mean, that's our plan for the zombies.
Yeah.
But zombies often interrupt is what I remember from Shaun of the Dead.
That's
You're just kind of trying to live your life. And
you can't plan for zombies.
Yeah.
So we're gonna do zombies next time, I think.
Nice.
I think it's really good. Okay.
So homework, watch Shaun of the Dead.
Yeah. In preparation for Wednesday's class, Shaun of the Dead, please. Okay. Now, thanks, Sam. We're totally going to go it slow. I always find myself rushed for the zombie stuff.
Which is not zombie, right?
Which is not.
Like that's 28 Days Later.
Yeah.
That's rage. That is not zombie.
Okay, so we're going to slow this down a little bit because I hope you're enjoying the discussion. So let's take a look at the distribution of humans within this space. I hope you recognize this space because Guelph is there. Can you please, this is going to be good now. We're not rushing.
This is really good. There's some good thoughts about biases that are going to come up here.
Can you please go ahead and together, collaboratively, show us where the humans are on this map? This is the first time we're doing this and I'm going to love this. Look at you. Where are the humans? Very good. That's funny. Good. Okay.
Not right there at the tip of Long Point.
That's the only spot. That's the only spot. Okay. Amazing. So tell us, is this a clumped or an even or a random distribution? What distribution is it? It's so fun. What have we got?
Clumped is the first suggestion that I see.
Are we good for clumped?
Is also the second suggestion I see.
Okay. Nice.
Clump, 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 clump,
clump, clump, clump. Yeah, good.
Clumped around big cities. So I'll push a little bit. So around big cities, what are the big cities around?
Yeah, what's the resource? So remember, if we're clumped, we're usually in association with a resource.
A herx around water. But what kind of water?
Go. Yeah. Oh.
Fertile land. The earth is our clump.
Yeah.
Clumped around money.
R. Alvarez. Good.
Yeah. Fresh water.
Yeah.
Lakes.
Excellent.
Drinkable water, fresh water.
Andrew's writing here. Freedom? No. Freedom! No. Fresh. Good. Fresh water. Love it. Yes. Excellent.
Intersections of moving water into lakes.
That's right. So a lot of these places, not only fresh water just because we need fresh water, but a lot of it had to do with a colonial history, of course, right? And an invasion history, right, of Europeans into North America. And a lot of these places were where ships could get to, the farthest inland ships could go. So these are freshwater ports rather than freshwater drinking, right? It is the resource that sort of established where the clump would be. Obviously, we benefit from fresh water from drinking, and there's a lot of fresh water in North America. So it's more about shipping lanes rather than drinking. And it represents, a crystal clear relationship with the colonization of North America. Because if we took a look at where the distribution of humans were before settlers came, invaders came, it would be quite different. And so we need to recognize that the reasons for clumping had changed over time. And here we go. I'm going to have to clear again because your map is amazing. And when we zoom in, though, we see some differences. And I hope that you appreciate, again, this whole idea about scale, changing the conditions, changing the relationships. Because if we zoom in, what type of distribution is this? So what do we see? What type of distribution have we got here? Yeah.
Even.
Yeah. Yeah, exactly. The burbs.
Lovecraftian.
That's awesome.
Little boxes.
No, I hate that song. Okay.
Little boxes full of ticky-tacky.
I hate that song.
You liked Weeds, though. Season 1?
Yeah, it was okay. It was okay. Okay, so an even distribution in a clump distribution, depending upon the geographic scale, right? I hope you see that. And that's really important. So seabird colonies are the same thing. The colonies themselves are clumped around resources. But when we zoom in at a smaller scale, they become even distributions. And that simply speaks to what's going on, what the driving variables are, right? And it tells us a ton about the biology of that species, which is really important. And also the environmental context. So, yay.
Is that a kaiju? What are we looking at? I love it.
It's fantastic. Okay, good.
That's very good.
Now, tell me though, within the house, what is the distribution? So you've got a whole bunch of, roommates, or you're living with your family members. Where are you within the house? What is the distribution of the people within the house?
Well, if that's on my street, I'm in the basement.
What's the distribution inside your house?
Random. Is it?
Is it?
That's interesting.
That's
a good
hypothesis.
Because a bunch of you have that hypothesis.
Great.
Random, as far away from each other as possible, which is more mechanistic. That's not random.
That's not random.
Depends on the house layout plan. So resources.
Right. Good.
Even.
Good. Yeah, if you've got roommates, right, you're all evenly distributed in your own rooms. You keep the door closed all day. You go downstairs for 2 minutes to make something, and you go back to your room. At least that was my university life. Oh.
Now, think about it also, because I like the scenario that you raised, but then think about that scenario in time, pre-pandemic, first year or first month of lockdown, and now kind of entering our third year of pandemic.
Also very different.
Has that changed? As the environment has changed, has your use of that interior space changed?
Yeah. Now in our house, we're very privileged. We have multiple living rooms with multiple couches and comfy places to sit. And where do we congregate?
The kitchen.
Standing up, leaning against the counter in the kitchen. This is where we spend 90% of our family time.
Yep.
For some reason, I spent a lot of time in the Maritimes doing my undergrad and doing my master's. So kitchen parties were like, a thing.
In the Ottawa Valley, the kitchen is where you go. And then if you're not in the kitchen, you're probably going to sleep or you're outside.
That's right. So cooking and drinking together is kind of the thing that we do. That's the resource, is the food and the beverages, and we congregate in the kitchen. So it's clumped in our house.
Wait, did the kaiju just get a Targaryen? I'm really confused. What's going on here? Oh, did you watch it last night?
No. Shh.
Don't be nice. Never be the nice guy.
Yeah. I'm watching this thing on Apple TV. What is that one called? Shamarantan?
Snuffleupagus?
No. It's pretty good. Okay. Good. Moving on. Resource. Oh!
Winter came.
Yeah. Okay. Super good. So let's kind of like associate them specifically with what's going on, what some of the reasons might be. But I hope you understand that there are like multiple reasons for explaining different distributions, right? And what we're interested in as biologists is how might we study, how might we set up an experiment or a design to be able to answer what the driving factors are for this particular distribution, right? So how resources are distributed in a habitat are usually associated with clumped distributions. Or if the resources are being protected by individuals, they might be associated with an even distribution to represent sort of a territoriality, right?
So for the interior of your house, some of your who are sharing the observation about kitchens and the importance of clumping in the kitchen until the territoriality of grandma or who kept saying, okay, get out of my kitchen, then you dispersed.
Yeah, you disperse, right?
And maybe there's a seasonality
right
where you came back.
Super.
When they didn't notice.
Yeah. Types of interactions among individuals, right? So is there cooperation or territoriality? And also the dispersal mechanisms, right? So clearly if it can't disperse to that area and it can't, occupy that space, then that's not going to be part of the distribution. We have a few minutes. We'll do carrying capacity and then we're going to stop pre-zombie. So carrying capacity is a thing, right?
PZ arret.
That's right. What we're going to do is we're going to take a look at that curve, the what's going on, nothing's happening, oh shit curve. Okay.
Oh, yeah, this is great.
Yeah. This is kind of what we were noticing with the moose, right, going up, and with the hippos, right? This whole like nothing's happening, oh shit, right? And it's a really classic curve in ecology. It's kind of the way that you describe population growth. And it's also really important to recognize what is on that y-axis and what is not, and what can be inferred and what can't, okay? So on the x-axis, time, okay? And on the y-axis, we have population size, okay? And in the middle, we have this inflection point. So we also have it maxing out, so reaching saturation, reaching a maximum. And so now we have questions. What kind of factors limit carrying capacity? So that's what that's called when it maxes out. Basically, the population size does not increase. So what kind of factors? Pop them in the chat.
Food, availability of resources.
Good.
Yep.
Yeah, super. Okay. How can carrying capacity change over time? So what could you do to actually increase this line, to push this line up?
Space and water now augment food as well, resources. What kind of things might change? More food.
More space.
Increase space, increase territory.
Yeah.
Resource availability.
Yeah.
Yep.
It's about the habitat, not about the species, right? The carrying capacity is set by the limitations of the environment. Yeah. So in one environment, it could be low, and in another one for the same species, it could be high if the space is bigger or the concentration of resources, okay? Cool. What does the point in the middle represent? What's going on at this point?
An inspiring speech.
You guys are really funny.
The exactement a Herrick's, the oh shit moment.
The oh shit moment? No. Actually, can I correct? So this is the oh shit moment. Yeah. Right here, where you're going, oh, slow down. This point is actually the, oh, okay. Because before this point is where the population growth is exponential. We're all pretty good at exponential growth, right? Unfortunately. And here is where the population growth rate, it doesn't stop growing, but the rate starts to slow down.
So Ms. Raga, the point where change in population starts to decrease. Yes, that's exactly right.
That's really good. Okay. Yeah.
the problem is for us is that we're often, as a species, not good at appreciating that change,
No.
the pre and post. And if anything, that we've demonstrated that over the past 2.5, 3 years.
Yeah. Okay. I want to spend some time on this, so I'm
Yeah.
really glad that we have 3 minutes, because otherwise we would have been pushing through. Okay. On these curves, then, things can be happening in a population. What I would love to see, if you wouldn't mind, is pick a letter and tell us what might be happening in the population at that time. Okay, so what could be, tell us the story of A, B, C, D, or E. What might be going on there? So type the letter that corresponds to a place and tell us what might be happening in that place. And we will.
Yeah, and you do it in the order that you want.
Yeah.
Right? Because if you don't have to work from left to right on the graph, you can go like, okay, I'm most confident about this.
Yep.
And I see a bunch of you are most confident about the carrying capacity. E.
E.
That's
Good.
great. And then A, we've got some
good.
ideas. A species is introduced into a new area, like the moose. Perfect.
Yep.
Exactimo.
Super good. A is good. E is good. The population has reached the carrying capacity. That's great. A. B. Oh shit moment. Yes. So in the oh shit, what's happening in the oh shit moment though? What might be happening to the population where the growth rate is really starting to pick up?
C. Resources are decreasing.
Good.
It's interesting. I like it.
An increase in reproduction.
D. Population growth has begun to slow since the population size and resources have begun to reach equilibrium.
Okay.
D. Population is moving towards carrying capacity, more competition.
Oh, that's good. That's good. Carguden.
Yeah.
Sorry.
Yep.
Yeah. Fantastic. Discovering that no one can outcompete them, right? So yeah, the B moment is basically a realization, like a evolutionary realization, that there's a lack of competition. Right?
They're Targaryens that have arrived in Westeros.
And they have dragons.
They're like, we have dragons. This is going to work out for us.
Yeah. Good. Okay. Really good. Yeah. A, humans introduce monkeys, yes, to Madagascar because they don't like lemurs. Yeah. That's good. Okay. Good.
Yeah, these are good.
Well done. This is great.
Yep.
Delighted. Okay. What's up next? We're gonna
there's a couple more.
This is good. Okay. So let's take a look at humans. And the history of humans. So, feel free to write in the white space here or to write in the thing. But does this follow that S curve? Does that work for us? Do we see that? And what's going on? And so carrying capacity, right, is going to be changing potentially for species. And within the history of humans, it certainly has changed a lot due to our technology, which is our phenotype, I would argue, right? We can't really be separated from our technology and the things that we build and do. That was a get your children. So we see these fluctuations over time and these dips as well. At this first heart, the bubonic plague, right, had a significant. Oh, and if you're at all interested, there's some very interesting research that has just come out about the plague and the genetic effect that it had on humans, on the species. So check that stuff out. It's like in the Guardian and Washington Post and stuff like that. But anyway, what we see after the bubonic plague is this dramatic increase, right? We have the Industrial Revolution and we see it going, oh, wait a second, maybe it's going to reach carrying capacity. We're no longer in the oh shit moment. We're in D over here. And then the Industrial Revolution.
And then penicillin.
Oh, sorry. The Industrial Revolution is there. Sorry. Yeah. And then medicine, which totally messes up our carrying capacity, right? Because now we can live in closer density and greater populations without sort of experiencing the direct effects or the consequences of that to our health. And that totally, again, we're almost reaching carrying capacity and then, whoa, penicillin. And things are still going up. Now, what is the current estimated carrying capacity for humans on the planet? Does anyone know? What happens next?
I guess for 8 billion.
Yeah. 3? No.
I guess for
hopefully
12
not.
billion.
Yeah. It's probably somewhere between 8 and 10, right? And what's going to happen at that point? Who knows? There could be another revolution. There could be like, colonization of the moon or Mars. Who knows what's going to happen with respect to our carrying capacity. But currently, it's estimated to be somewhere between 8 and 10. And given current situations, there's been all sorts of really cool research and thinking about why it really cannot get to be higher than 10 billion given the current context. And with that, we will zombie next time. And thank you so much for joining, and thank you so much for all of your participation and enthusiasm. We'll see you next time.
And we'll be back here in 2 seconds.
Yeah,
and we'll
if you want to talk
until
about
we turn off the recording.
IT challenges.